Hello there. Today we are going to look at the indeterminate form of limit. Indeterminate form of limit. What do you mean by indeterminate form of limit? Let's assume that this particular question here, we are saying that you should find a limit as x approaches 1. If we substitute the value of this x here and to this place, and we get an answer of 0/0, it means that this is what we call indeterminate. Indeterminate, okay? When the numerator and the denominator are the same, or means they are 0, then it's indeterminate, not they are the same. But when it is 0, it becomes indeterminate form. What it means is that this limit exists somewhere. So we have to do further simplification or algebraic simplification to this. That is what we mean by indeterminate. So let's look at how you can tackle a question like this. So as I said, first you need to test them. So in doing so, first one, the limit as x approaches 1 of x minus 1 all divided by x squared plus x minus 2. Now here, I will put 1 here, I'll put 1 there, I'll put 1 there. When I do that, I have 1 minus 1 all divided by 1 squared plus 1 minus 2. And you can see that 1 minus 1 is 0. 1 squared plus 1 is 2 minus 2 is also 0. So we can call this one as what? Indeterminate. Is that okay? So for that matter, you need to do some algebraic simplification there. Some algebraic simplification. So looking at this, if I look at the down here, x squared plus x minus 2, that's quadratic, okay? So like if I have x squared plus x minus 2 is quadratic. So for this quadratic, I can simplify it. Now, we need a number, two numbers, so that when I add them, I'll get 1. And when I multiply, I'll get negative 2. Is that okay? So that is going to be negative 2 and, positive 1, positive 2 and negative 1. Is that okay? When you add 2 to negative 1, you are going to have positive 1. When you multiply 2 to negative 1, you get negative 2. So in this case, here I'm going to have x squared plus 2x minus x. So I will replace this x by this and that, minus 2. Now this, I can group them together. Now this x is here, x is here, so x will come out, leaving x plus 2. Negative is here, negative is here, it will come out, leaving x plus 2. The trick here is that when you do it, make the one inside here must be the same. So here will be x minus 1. That is the outside one. Then you pick one of the inside one. So this is what you are going to have. So in place of this, I'm going to put this one there. Is that okay? So let's see it. So you are going to now have the limits as x approaches 1 of x minus 1 all divided by x minus 1 x plus 2. So that you see this and that are the same, so they will cancel. So when this cancel out, you are now having the limits as x approaches 1. So here you have only 1 here. Then you have x plus 2. So this can go into s of 1, leaving 1 there, isn't it? So we have x plus 2. Now at this point, you can apply the limit on it. And remember how to apply the limit. The limit as x approaches 1, you apply it on this, all divided by the limit as x approaches 1, you apply it on this. For this one, you are going to have the same thing. the limit of a constant will be the same constant. Here I'll put 1 here, that will be 1 plus 2. So you are going to have 1 over 3. Is that okay? So this is what we call the indeterminate form. You only test. You only test. Okay, so now let's look at this example. Evaluate the limit as x approaches 5 of this x squared minus 25 all divided by x minus 5. First thing, you test to see whether it will be indeterminate. If you get an answer straight away, that way you don't have problem. So when you are testing, means that you are going to have the limits as x approaches 5 of x squared minus 25 all divided by x minus 5. So if I put 5 here, I'm going to have 5 squared minus 25 all divided by 5 minus 5. 5 squared is 25. 25 minus 25, that will be 0 over 0. So this is what? Indeterminate. It means that the thing exists somewhere, so we have to apply algebraic simplification. So what you are going to do here is that you apply the algebraic simplification. So the limit as x approaches 5. Now this is difference of 2 squares. So this x squared minus 25. You know difference of 2 squares, I have a squared minus b squared. I can write it as a plus b, a minus b. Is that okay? So this is how it will look like. So this one, I can also write this one as x squared minus 5 squared all divided by x minus 5. So by applying the law, we are going to have the limit as x approaches 5. This as x plus 5, x minus 5, all divided by x minus 5. So that this will cancel this. And I have the limit as x approaches 5, x plus 5. Is that okay? So this is what we have. So we now apply the law to it. The limit as x approaches 5 of x plus the limit as x approaches 5 of 5. So looking at this one, the limit of this, that will be, I'll replace this x by the 5. So we are going to have 5 plus, well, this is 5, but it's a constant, so you maintain a constant, so 5. And that gives you 10. Is that okay? Now let's look at another example. So okay, now let's look at this example. Evaluate the limits as x approaches 1 of x cubed minus 1 all divided by x minus 1. So let's test first. So first we have the limits as x approaches 1 of x cubed minus 1 divided by x minus 1. So with this one, when I put 1 there, I'm going to have 1 cubed minus 1 all divided by 1 minus 1, which will give us 0 over 0. So this is indeterminate. So since it's indeterminate, we have to do algebraic simplification. How do we simplify something like this? This is not a square. This is a cube. So if you want to simplify, first you have to use long division to do this. So what you are going to do is that x minus 1 dividing by x cubed minus 1. So we're going to divide this one by this. Is that okay? Now first thing, x can go into x cubed how many times? X squared. So x squared times x will give us x cubed. X squared times negative 1 will give us negative x cubed. So you subtract. When you subtract this from, you see that will be 0. Now negative 1 minus, so again will be put here. So this will be x cubed squared minus 1. That is how it's going to be. Now, know that this will be x plus x, because x can go into x squared, x times, so that x times x will be what? X squared. Is that okay? Then minus what? X. So we subtract. X squared minus x squared will be 0. Then so that will be x minus 1. Is that okay? So x can go into a of 1, so plus 1 here. 1 times x is x. 1 times this will be minus 1. You see, when you subtract, we get 0, 0. Is that okay? Very good. So this what you are going to have. We are going to have this times this. Is that okay? So see how I'm going to write it. So when you simplify this, so realize that when we simplify the x cubed minus 1, we are getting x minus 1, then x squared plus x plus 1. Then all divided by the original thing, the x minus 1. So you see this will cancel with this one. Is that okay? So that now I have my limit as x approaches 1 of x squared plus x plus 1. So now you apply the limits on each of them. Is that okay? So when I put 1 there, I'm going to have 1 squared plus 1 plus 1. This is a constant, so I'll maintain. 1 squared is 1 plus 1 plus 1. That's going to give us 3. Is that okay? Very good. Now try this. Please try this and leave your answer in the comment section.